So we are going to start our next and the last chapter here, which is chapter 15, which is on the applied trig. Now we'll start this chapter with some quiz questions, because these questions are based on chapter 9, pretty much like basics from triangle, circles. So which triangle is the right triangle? A, right? This one, the left one, and this is the right angle, right? Okay. Which triangle? Again here, right triangle. C. By the definition, a right triangle has always one 90-degree angle, right? If the right triangle A is here, A is in the right triangle, in the angle A is 60, how much would be B? Because this is the angle A, right? If that is 60, this is going to be 30, right? Because you know the total is always 180, and then you know the C is the right angle, which is always 90. So you know this one is 90, this one is 60. You can subtract it from 180, right? So to know what is the right answer is D, right? Again here, if A is 40, B is 50, right? So you can always think like this, that the A plus B, meaning the angles without the right angle is 90, meaning A plus B is 90, right? So the right answer is 50, right? Right answer is 50, A. If A is 70, B is 20, right? Because A plus B is always 90. Right answer is A. If A is 45, B is 45 as well, right? So right answer is D. If A is 30, this is just an angle. So if A is 30, B is 70, how much is C? 80, right? Because it has to be 180, the total. So right answer is B. A is 40, B is 80. So it's 60, right? C is 60. Right answer is D. Again, if A is 60, B is 60, C must be 60, right? So right answer is D. Okay. Now, this is a very famous theorem, which actually is based on a right triangle. So most of the discussions in the trig is actually based on the right triangle. Okay. So again, we pretty much know the right triangle, but let me just introduce the right triangle in a different manner, because we know that we have three different angles, right, in the right triangle. But here, almost all the time, we will write capital C for the right triangle. I'm saying the right angle, because this is a convention. Then we always use a capital C for the right angle. For the other two angle, we will call one as A, capital A, and other one as capital B. But we will also have to identify the sides. So what we do is, since this is the angle C, the opposite side of C is called small c. You know what I'm saying? So this is the case. So all the angles are identified by the uppercase letters, and all the sides we use lowercase letters. You know what I'm saying? So for an example, if the angle is C, capital C, opposite side would be lowercase c. Okay. If the angle is A, this is the opposite side, right, which is used as small a. If angle is B, this is the opposite side, right, of this angle. This is small b. Now the Pythagorean theorem tells that in any right triangle, do you remember that C was called hypotenuse, right? Which is actually the longest side of the right triangle, right? So that C is equals to square root of A square plus B square. That means if you know 2 of the sides out of 3 in the right triangle, you can use this formula to find the other one. Okay? And this angle here is actually designated by a Greek symbol theta, which means an angle less than 90. Because this cannot be 90, right? Here we actually twisted the formula a little bit every time. So we wrote the formula in 3 different manners, but this is actually the same formula. So we have written those in 3 different manners because we just wanted to show you that if you know any of those 2 sides, you actually should be able to find the other one using this formula. So it's something like solving the unknown. If you just know, if I give you a right triangle, and if I tell, okay, I have this right triangle and I have these 2 sides, can you tell me what is the other side? So you'll be actually using any of this formula, okay? Meaning, if you know A and B, you will be using this one. If you know, let's say, C and B, you'll be using the middle one. If you use C and A, you'll be using the right one to find the B, right one. Okay, and this is a very important formula in trigonometry. We solve a lot of real life problem as well. Let's look at a real life problem that we can solve using the Pythagorean theorem. A boat crossing a river is subjected to 2 forces, the boat's motor and the river's current, right? Because the boat's motor tries to cross the river, but the river current actually tries to move the boat towards the current flowing, right, that direction. The latter will cause the boat to land downstream. If the river is 300 meters wide, the total distance the boat travels is 500 meters. Because, you know, it cannot actually cross directly. It has to go like this. So for an example, let's say this is the width of the river. Okay? So in general, what should do? Let's say if the boat is started from this point, it should go from here to here directly, right? But due to the current, it actually cannot go from here to here, but instead it can go from here to here. Okay, do you see what I'm saying? Because of 2 different forces, okay, which actually put it to a little bit longer distance from here. So now let's say if you really know that the width of the boat is, width of the river is 300 meters, and the boat actually traveled this 500 meters. Can you find the downstream distance, this distance? Of course you can, just using the Pythagorean theorem. Because this looks like a right triangle, right? You see there is a right angle here. So which formula you will be using? You know the hypotenuse, right? This is the hypotenuse, right? This is 500. You know one of the other side. If you know the hypotenuse, then you will be using either of these 2, right? Meaning you know hypotenuse, you know another angle, right? So that's exactly what we are doing. So we'll be using B, right? Do you see B here? Square root of 500 meters square minus 300 meters square. If you solve this problem, I'm saying math, you'll get 400 meters. That means the downstream distance here is actually 400 meters. So if you solve this, then we'll get the answer. I'm saying if you use your calculator, you can find it, right? So the right answer will be C. We can try another example here. This is from electric circuit class. Let's say we know that the impedance Z is actually square root of x square plus r square. So it's pretty much like a right triangle. So that means if you know the resistance, which is R, and if you also know the reactance, which is X, you should be able to find the Z, right? Now Z here is hypotenuse, right? So you'll be using this formula here. because the hypotenuse is unknown. So what you do is, whatever is unknown, you actually keep that at the left side, isolated, right? So I'll be using this formula, so which will actually be look like A, right? 660 square plus 105 square of a square root. Can anyone try and see how much is the answer? Just to make sure you can do it. All right, so you got the right answer here, which is 121. Okay, C. So this is a similar question here. So you pretty much know the S and Q. You have to find the P. But right now you know this, know the hypotenuse. You know another side. So you can use B, right? So square root of hypotenuse square minus another side square, right? Which will give you 40. So the right answer is P equals to 40 watt. P is actually the power, which is the electric power in electric circuit class. All right. So again, let's introduce some more parameter of the right triangle. Now we know the hypotenuse, right? We know the sides, and make sure we know that upper cases are used for the angles, lower cases are used for the side, right? And again, opposite sides are used, opposite sides are actually the side which is opposite to the angle. For an example, if C is the angle, opposite side will be called small c. You see what I'm saying? Which is the side. And you also need to understand which one is called adjacent side. For an example, if C is the angle, the opposite side is a small c. But other two sides, for an example, this side is an adjacent side, right? This side is another adjacent side to C. You see what I'm saying? Now, if this is the angle A, which one is the opposite side? Small a, right? But other two sides will be called, especially this side, will be called the adjacent to the angle A. Because this is already hypotenuse, right? The longest side. So you need to identify those. So a lot of times you might see that A is moved here, because this is possible. And similar manner, if A is moved, we actually make this small a as opposite side, because we just keep that convention that opposite side will be the same letter but in lower case, right? But make sure we understand the opposite and adjacent side. So even if you see that right angle is represented in many different manners in trigonometry. So all you need to do is you have to identify which one is the right angle, which one is the hypotenuse, and other things like right triangle. I'm saying the right triangle and right angle and the adjacent sides of different angles, right? For an example, if this is A, this is the opposite side of A, right? And this is the adjacent side of A, right? Because this is the right angle, so that means this is the hypotenuse. So no matter how the triangle is oriented, you should be able to identify these. Now let's try some quiz questions here. In a right triangle, the opposite side, the side opposite right angle is called what? Hypotenuse, right? B. In the right triangle, A is what? Small a. Small a is small a. It's not C. It's not hypotenuse. The small a is this one, right? Is actually opposite to angle A, right? Which is B. A small a is also what? Adjacent to angle B, right? Okay, now a small b opposite to angle B, right? So right answer is B. Small b is opposite to angle B. Now here small b here is also adjacent to angle A, right? Small c is hypotenuse. Right answer is C. Angle C. Now, do you see the difference? Anytime we mention angle, now is capital letter, right? Angle C is what? 90 degree. Which one is the hypotenuse? The following. Small c. Be careful, not the uppercase, lowercase one, right? Which one is the hypotenuse here? Because a lot of times you might see different letters instead of A, B, C. Hypotenuse is what? Number 3, right? Which is the 90 degree angle? Z, right? Which side is adjacent to angle X? This is my angle X. Now which is the adjacent side? Number 2, right? Because this is the hypotenuse. And this is number 2, which is adjacent to X. So right answer is B. Which is the side opposite to angle X? This is the angle X. This is the opposite side, right? Number 1. Now let's introduce all the trigonometric functions. All these functions are actually coming from right triangle. Okay, so this is pretty much the ratio which is almost constant for every single right triangle you can draw. Okay, but we'll talk about how you get these. Okay, but first we just need to know their names. Now this is called sine and sine function, and then with every function there is an angle, right? So let's say sine 30 is 0.5, sine 45 is 0.707, sine 60 is 0.866. You don't have to memorize any of these because your calculator has the ability to find all of these. If you just press sine and then let's say 60 and then click equal sign or enter, it will automatically give you that fraction. Okay. So all these are cosine. This is another ratio, and again these are constant. And the last one is called tangent. Okay, sine, cosine, tangent. Right? So all these functions take one angle and it gives you a ratio in return. Ratio is given as a decimal fraction. Okay? Yeah, and press type 30. Yeah. Yeah. So sometimes the calculator might give you a different answer because your calculator may not be in degree mode. Because remember, I'll show you to some of you if your calculator is not giving the right angle, because remember the angle can be measured in degree, or it can be also measured in radian. So probably your calculator is in radian mode, so it's actually calculating sine not 30 degree, 30 radian, which is completely different than 30 degree, right? But I'll show you how to change the mode from radian to angle. Okay, so we can change the mode, right? If we go to mode, you'll see the radian and degree. Select the degree, press and enter. Most likely it will be working. And there are different calculators, so some calculator might be different, like basic scientific calculators has different way of doing it. Okay, so make sure we always understand these. Now, there are some trigonometric functions. These are called inverse trigonometric functions. Okay. Now again, these are like functions, but this does the inverse thing, meaning, see, this one is called sine inverse. Do you see there is something to the power -1? So these are inverse function. Now inverse function actually does the reverse one, meaning this takes the fraction and gives you the angle, just the backward part. Meaning a lot of times what happens is you might know the fraction, but you just want to know what is the angle. Is again your calculator has the inverse functions. So if you just press the inverse function and press this fraction, it will give you actually the angle. But make sure you change the calculator to degree mode so that the angle is given in degree, okay? You can try a couple of these ones to see whether your calculator is working right. I'm saying these are pretty constant, okay? So this is the important part. So make sure our calculator is set to degree mode. When it is set in radian mode, it's still working, but you have to consider the angle in radian. You know, we're a little bit more comfortable probably with degrees, right, than radians. So we prefer the degrees maybe. Let's try these. I'm saying, you know, we'll try and see whether we can find it using the calculator, right? What is sine 30 in your calculator? Check that. Is it 0.5? Right answer is C, right? Sine 25. Just press sine and 25 and equal sign. I think you have to press sine first, right? You have to press sine first and then 25 and then equal sign. How much it is? D, right? 0.423. Cosine 25. So what do? You first press cosine. Press cosine. Okay. Yes, COS. Yeah. And then press 25 and equal sign. How much is that? 0.906. Okay. Cosine 70. Yeah, it's giving the answer, right? Oh, these are, sometimes you might get the answer in, you have to change the scientific mode to the normal mode, okay? So this was in the scientific mode because probably you tried some scientific calculations before, right? So cosine, let's say 25, enter. So this is like cosine 70. What is the answer? 0.342. Okay. So tangent 70. .75, right? Tangent 15. D, right? A? Okay. See, I don't remember all the values, but whatever you're saying. So I think it's right because most of you are getting the same answer. 0.268, right? Okay. Let's try some inverse function. You should have some inverse function, okay? So select the inverse function and then press that enter that number, 0.643, and see how much is there. 40 degree. Did you all find 40? So when you select the inverse function, most likely you have to select the second and then select that bottom, right? Okay. You have to select the second and that bottom. Okay, so the right answer is 40 degree. Sine inverse 0.985. $80. Okay. Cosine inverse 0.766. $40. Okay. Cosine inverse 0.819. B. 35. Okay. Tangent 0.176. Tangent inverse 0.176. $9.98 degree, right? Tangent inverse 3.08. $72. Okay. So we now pretty much will be able to find the trigonometric functions, right, and inverse functions. Now a lot of times, because as I said, trigonometry, all the functions and all the theorems is actually based on the right triangle. So we try to make and change things to make everything right triangle. Okay. So for an example, let's say if you are given an obtuse triangles, because I know that in the obtuse triangle you cannot work with the obtuse triangle. So instead what you can do is, let's say the yellow one is actually an obtuse triangle. Because, and what we did is we actually have drawn a line here to split that triangle into two separate triangles which are both right triangle, and then we can apply the formula of the trigonometry. You know what I'm saying? For an example here, another one, you see this is actually a triangle. The yellow one is a obtuse triangle, right? So what do is we extend this a little bit and make it a right triangle, and then we apply the theorem. So pretty much you can apply the Pythagorean theorem. You can try all of these trigonometric functions on it. Okay. So a lot of times we try to tweak it, twist it a little bit, add or do something so that it becomes a right triangle. Okay. Okay. Now you see how actually all those things are coming. Remember those numbers? When you press sine 30, it gives you 0.5. You might be wondering how I'm getting this 0.5. Why it is constant? Now you probably get that answer. Basically, it's all coming from the right triangle, because sine means the length of opposite sides divided by the length of hypotenuse. And this theta means the angle. That means if you draw a right triangle where, for an example, theta is 30, where the theta is 30, the ratio of the opposite side, meaning this side, and the hypotenuse, longest side, will be always 0.5. That's very interesting, meaning your triangle may be bigger, may be smaller, but the ratio is always 0.5. That means technically if your angle is 30, meaning the theta is 30, that means your hypotenuse is actually double of the opposite side, right? That's why you are getting 0.5 as the ratio. That means ideally, no matter how big or small you draw the triangle, the ratio is always 0.5. And this is exactly where all those numbers are coming from. And that's why those are constant, okay? Based on the angle, because as soon as the angle is changed, the size and length of the sides are different, right? And that's why the ratios are changing, but those are constant for a specific angle, okay? So you see here, cosine is actually the length of adjacent divided by length of hypotenuse, and tangent is length of opposite by length of adjacent. And all of these opposite, adjacent is actually determined based on theta, meaning where the angle is. You know what I'm saying? Because if this is the angle, this will be the opposite side, right? You know what I'm saying? And this is going to be the adjacent side, this side. You know what I'm saying? Yeah. And we know the hypotenuse. Okay. Now to make it simple, from now on, instead of saying length of hypotenuse, we'll be just saying hypotenuse. So we know that is the length. So that means sine theta is opposite by hypotenuse, cosine theta is adjacent by hypotenuse, and tangent is opposite by adjacent. Okay, to make it a little bit similar. So it's the same thing, but instead of just saying the long name, we'll just make it short. Now the inverse function is pretty much the same idea, because inverse function give you the theta, and the number you are getting is actually a ratio, right? So you know the rest, right? For the sine is actually the opposite by hypotenuse, cosine adjacent by hypotenuse, and tangent means opposite by adjacent. Okay, you don't have to memorize most of it, but you have to understand it, because you'll be given all those in the questions in the hint section. So you will see all of it, but you'll have to identify which one you need for your specific question. For an example, all of those ratios we can tweak and twist to write the same thing in different manner. Okay, so it's pretty much the same thing we have written in different manner. Okay, so and the good part is this: if you really know some of it, you'll be able to find the rest of it. Meaning, let's say if somebody said, okay, this is the value of the theta, this is like your hypotenuse, you can find something else from there using this ratio. That's why these are so powerful. Okay, You don't have to know a lot of things. If you just know a little bit of something in the right triangle, you can use these trigonometric functions to know the rest. We'll show you some examples today so that you can understand how you use it. Okay. Again, trig functions and the inverse functions. Okay, and we are even writing everything in more short format, right? Instead of writing opposite, we just write OPP, right? It's opposite. Hypotenuse is HYP, adjacent is ADJ. We understand, right, what it is? Okay. Now, let's try some example here. I'm saying the quiz questions here. If you are given A, small a, right, and given the angle A, which substitutions are true? Can you check the following list? Because you actually have to identify what you are given so that you can apply the formula, right? What you are given. Can you identify what you are given? Remember, opposite side is always determined in terms of theta, right? Let's say, for an example, if you think this is your theta, the opposite side will be this one, right? But if you consider this as theta, the B is a theta, right? Then the opposite side is actually this one, right? See, that's the point. Meaning, whatever the angle you are given, based on that, you will determine which one is your opposite side and which one is your adjacent side, right? All right. Can we identify what are given here in the question? You are given a small a. You are given angle A. That means you are so the angle A is actually your theta, right? And a small a is what? Your opposite side. So the B will be hypotenuse? No, right? B cannot be hypotenuse. Maybe this one is right, the last one. Angle A is theta. Automatically the small a will be the opposite side and a small b is the adjacent side, right? We have to identify which one is what. Okay, now let's say you are given a small a and a small c. Anytime you have a small means what? Side, right? And which formula would you use to find the angle A? Angle A is this one, right? Now, if you look at this from the list, all you need to know is A is something that you are looking for, right? So A must be isolated. So that means you can rule out option A and option D. The only option you will be left with is B and C, right? Because in the B and C, angle A is isolated, right? In the left side. You see what I'm saying? Option B and option C. Now, can you tell me which option is good for you? Remember, you may have multiple options, but you'll be selecting only the one which is good for you, meaning you know pretty much all of it. For an example, let's look at option B. If you look at option B, what do you need to know for option B? A small a and a small c, right? So which you already know, right? You see what I'm saying? So it's the best one. But if you select the option C, you need to know a small a and a small b. Do you know a small b? I'm sorry? Oh, you can find it, but I'm saying you can find it directly. I'm saying you can always find a small b using some other formulas, right? I'm saying, but in the question, you are directly given a small a and a small c, so which is pretty straight. I'm saying you directly find it instead of applying some more formulas to find it. Yeah. So the right answer should be the B. Okay. So that's how actually we determine which formula I need, because I'll be given all the formulas. So let's try another one like this. Let's say you are given a small a and a small b. Again, you are looking for a capital A. So again, you select between these two, and this time is, I think, option C is better option, right? Because you know a small b, you know a small a and a small b, right? And those two you need to apply here. Do you see here, small a and a small b? That's all you need to know. Because once you know a small b and a small b, you will know the ratio, right? And you can apply it to the calculator to find the inverse tangent function. and you'll know that because the inverse tangent function will return what? The angle, right? In degrees. So you'll know the answer. Okay. Now we actually gave you the list of all the formulas because it's pretty much the same formula. We tweaked and twisted these in 3. This is one formula for the cosine. We tweaked and twisted for these 3. And this is the tangent. We tweaked and twisted. And these 3, meaning that number 10, 11, and 12, these 3 are coming from the Pythagorean theorem. Remember we started with the Pythagoreans? Those also part of the trigonometry, right? Now, for an example here, you are given a small a and angle A. Now you are looking for angle B. Which might be the best one from the list? So you are looking for B, right? So B is isolated. So you are looking for B. B is isolated. Now, what do you need to know here? So the right one, I think this is the best one, right? A. Is that right? A. Because you are looking for B, and you know a small a, so you plug a small a here. You know angle A, you plug here, right? So once you plug the A, you automatically find the tangent A using your calculator, right? So, and then a small a is also given. So the B is your best choice. Because look at the other formulas here. You don't know C, right? You don't know C here. So that's the problem. You don't know C at this point, so you cannot find it. You cannot find it directly, I would say. You can find C using other formulas. Okay, now let's try different substitutions. Now the B is given, small b is given, angle B is given. Which substitution I'll be using? Of course the B is my theta, right? Angle B. Now what else? Small b is what? If B is the angle, small b must be the opposite side, right? So I think this might be my best choice, right? B is my theta, so small b is my opposite side, and automatically small a is my adjacent side, right? Because I actually have to identify which one is what so that I can apply the formula. Let's try some more questions here. Now, let's say we are given a small b and we are given angle B. Looking for A. Which one is the right formula here to find it directly? First one, right? See, I'm looking for a small a, right? So that should be isolated. And I know B, so I can plug B here. I know angle B, so I can plug angle B here. That's it. But if I choose this one, I'll run into a problem here because I don't know C. Because remember, using one formula, you can at max find one unknown. That means in any formula you are using, everything you should know except one. If you have 2 unknowns, there is no way you can find it. You can have at max 1 unknown. That's it. So if you don't know 2 of these, then there is no way you can find this using that formula. Okay. So the right answer is A. All right, let's try another one. Let's say I know 2 sides right now, A and C, and I'm looking for the third side. C is all about the side, right? None of the angle is involved. So the best formula would be D, right? Because look at the D. I know C and A, right? So using C and A, I can find a small b, right? This is coming from where? Pythagorean theorem, right? So this doesn't involve any angle. It's all about the sides. So out of 3 sides, you know 2 sides, and you are looking for the third one. So the right answer is D. Now let's try some example here. Okay. Now let's say I have an angle given which is 35. So you know that this is my theta, right? So this is my theta now, 35, because I know this angle. Now A is what? 6 feet, the small a, which is actually the opposite side, right? Now I will be finding B, small b, angle B, small b, and small c. Now let's start with the B first. Now which is the easiest part? Which formula I will be using to find the B? Look at the formulas here given, all the 13 formulas. You know the A, right? Can I use the formula number 13 for that? Because I know the A, 35. So B must be what? 55, right? You see what I'm saying? Because I know that A plus B must be 90. So that's probably the easiest. So I can find the angle B right away. So angle B must be 55. So now I have my B. So I listed the B here. So I know the B now. The more you know, the more flexibility you will have to apply the more rules, more formulas. Because sometimes for a specific thing, you probably will have multiple options. And no matter which one you use, you will still get the same answer. Okay. Now let's say we want to find B or C. Let's say we want to find C. Now remember, C is the hypotenuse, right? So let's look at here which formula I should be using for C. Now they said rule number 2. Okay, now let's go to rule number 2. Now this is the hypotenuse, right? So this is C. What is my opposite side? Now the opposite side, there is a catch here. You now know A and B both, right? Now if you think A is your opposite side, A is your theta, then you know which one is the opposite side, right? You can do that. But you can also consider B as your theta, then there will be a different opposite side. But make sure you stick with one, right? Either you use A as theta, then you know which one is the opposite side, which one is the adjacent side, you should be fine, right? Or if you assume B is your theta, then you do the same for B, okay? But there will be different one opposite side. But don't worry, since you know more than one angle, just use one. Let's say I stick with A as my theta, okay? Now if A is my theta, now this is my theta, right? Now this is my opposite side and this is my adjacent side now. So let's say number 2. If I go to number 2, what I need to know, opposite side and theta, right? Now what is my opposite side here? Small a. I know a small a, right? 6 feet. I also know theta, which is 35, because I used A as my theta. So I can use number 2. So number 2 is okay. Can I use number 5? Let's check number 5. Hypotenuse, which is C. Adjacent side. Do I know my adjacent side? Adjacent side is what? This one, right? Do I know my adjacent side? No, right? Because I don't know B yet. So this may not work. But let me show you a different way. Let's say if I assume that B is my theta. This is what I'm saying? B is my theta, right? Now what? Theta is 55. Now let's go back to formula number 5. Now B is my theta. So which one is my adjacent side? This one, right? Which I know, 6 feet. So I can now use this formula. So think about this. I can use this formula when I'm thinking B as my theta. I can apply the rule number 5, right? So that means 2 and 5 both are true. The only difference is in 2 you have to assume A is your theta, right? In 5, in 2, in B you have to assume B is your theta. But remember, you don't have to know all of it. I'm saying all you need to know is just use one formula and find it. All I'm trying to show here is that you will have sometime more than one formula to use, And no matter which one you use, you actually will get the same answer if you are doing it right. You see what I'm saying? So depending on how you're selecting. Now let's double check the formula number 10. Now the formula number 10, you cannot use formula number 10 because you don't know b, small b. You don't know that b yet, right? So you are not ready for 10. So the right answer is actually D, because you can use 2 and 5 both. You see what I'm saying? Based on which one you are taking as your theta. Okay, now let's say I use that. Let's say I'm using 2 or 5. Let's say I use 2. How do I calculate it? If I use 2, what is 2? Hypotenuse equals to opposite by sine theta, right? Now my hypotenuse is C. I'm looking for C. Opposite is 6 feet, right? And my theta is 35. Can you do this in your calculator and see how much you get as your hypotenuse? Because we selected, I'm saying now we are using formula number 2, right? I could have even selected formula number 5. You are looking for C, right? Yeah. How much is that? 10.5. So this is 10.5 what feet, right? Now let me show you if I would have used formula number 5, right? Then I'll write C equals to, now remember, now 6 feet is my adjacent, right? Because I am changing my theta. Now my theta is 55. Can you check this one? Formula number 5. This is the formula number 2. And formula number 5. Oh, I'm sorry, cosine 55. See? That's the same answer. That's the interesting part. So you can still use both any of these to get the same answer. Are you getting the same answer? All right, so you found the right answer for C is 10.5, right? Which is C. So we know what is, so we pretty much know all this now. We know A, we know B, we know small a, we know small c. Now, the only thing that we need to find right now is a small b. Which formula I should be using? I probably have more than one option for sure, right? Because I know a lot of things. So, interesting thing is you probably will be able to use all of it. Number 12, what is number 12? If you know C and A, you should be able to find B, right? You right now know A and C both. So number 12 works, right? Number 3, let's see number 3 here. Number 3, you are finding the opposite side equals to hypotenuse times sine theta. Now the hypotenuse is C, you know that. Now opposite means B, right? So if B is the opposite, you see what I'm saying? If B is your opposite, then the angle should be capital B, right? You know capital B as well. So you can use that. Number 3 works. Number 9 works because number 9 will be this one, right? Opposite equals to adjacent times tan theta. Now the opposite is what? You are assuming B as your opposite, right? If B is opposite, angle is what? 55, meaning this will be tan 55. That will also work because you know the adjacent, which is small a. Because if this is the angle, this is the adjacent, and this is the opposite, right? So 9 is work. Formula 6, if I go to formula 6 here, now you assume that B is adjacent side, right? Now if B is adjacent side, your theta has to be A, right? You know A as well. So pretty much you can use all of this formula. So your right answer is actually D. So you can use formula number 3, formula number 6, formula number 9, formula number 12. Now you see you have plenty of options. But no matter which one you use, you will get the same answer. Can you use one of these and find the answer for me? Maybe formula number 12. Just to use any of these, which one you like. So here we actually selected formula number 8, but that doesn't matter. Any formula, you know, as long as you are doing the math, you can find the answer. What is the answer? Okay, so my right answer for small b is 8.57, which is my option number C, right? So that's it. So we pretty much tried. So now what we learned is this. Using one formula, we can at max find one unknown, right? So everything has to be else has to be have to be known. So if you look at all of these formulas, most of the formulas you have like three parameter, right? So you pretty much have to know 2 out of 3, and you know the rest. And at some point, if you know a lot of information, you can use multiple formulas. Meaning, you know, but make sure the only catch is this: make sure you identify which one is your theta and which one is your opposite and adjacent, because based on the theta, opposite and adjacent get changed, right? So that's the tricky part. So we have 3 homework here: part 1, part 2, and part 3. You can go to the homework section and start working on the homework. And each of the homework we give you the hint. If you click the hint, you will pretty much see all of these formulas there. So you don't have to memorize the formula; you just have to use it. Which one is the right one?